Hey folks, welcome to my channel Number Pen. So we have the problem on your screen. Find the points of discontinuity of f of x where f of x equals x cubed minus 3 for x lesser than or equal to 2 and f of x equals x squared plus 1 for x greater than 2, right? So we notice that for all f of x lesser than 2, the function is a polynomial function of the degree 3, which is x cubed minus 3. And for all x greater than 2, it again takes a polynomial but of the degree 2, which is x squared plus 1, right? And at x equals 2, the function, as we move from the left of 2 to the right of 2, it undergoes a transformation from x cubed minus 3 to x squared plus 1, right? So if I divide this particular problem, divide solving this problem into three parts, right? My part one is x lesser than 2, and my part two is x greater than 2. And I'll have to examine the continuity of the function at x equals 2 because the function undergoes a transformation, right? And I'm not going to go into detail of part one and part two because we have done a very similar problem, and request you to take a look at my previous video. And part one and part two are polynomial, and my part one, which is x lesser than 2, right? What does it mean? It's belonging to the open interval 2 comma infinity. My f of x, which is equal to x square plus 1, right? So let's copy that. Is continuous, right? Right. And my part 2, which is my x lesser than 2, right? Part 2, my f of x, which is x cube minus 3. So let me copy that. Also is a polynomial function, and we can comfortably call this as continuous but in the interval 2 to minus infinity, right? And now let's go ahead and examine the continuity at f of x equals 2, right? Now, what is my f of x equals 2? We see that at x equals 2, the function takes x cube minus 3, right? So let's write that down. And at x equals 2, what is my 2 cube, which is 8? 8 minus 3, which is equal to 5, right? So there we have our f of x equals 2. And then we are left with calculating our LHL and RHL, right? So let's do that. And what is our LHL? We are approaching 2 from the left, right? And what is the function it will take? It will take x cube minus 3, right? So let's write that. And I'll have to call out my f of 2 minus, means that it is limit x tending to 2 minus h. So that becomes equals 2 minus h the whole cube minus 3. And I don't see a challenge. We will, h being infinitesimally small, when it takes the value 0, sorry, it will be equal to 5, right? And now I'm going to pull out my right hand limit, right? So let's do that. I do my right hand limit. I do know that what do I mean by my right hand limit when f x approaches 2 but from the right, which means that x takes a value which is greater than 2, right? So which is 2 plus, and it is going to take a value which is 2 plus h, where h is infinitesimally small, which means I'll have to replace it by an x square plus 1, 2 plus h the whole square plus 1, right? Which is nothing but my 4, which is 2 plus h the whole square. As h is infinitesimal, we can comfortably substitute h equals 0, and we have 4 plus 1 equals 5, right? So now, talking about continuity at x equals 2, let's take out our pen and check out if the conditions are satisfied, right? So limit exists, and why does limit exist? My LHL equals RHL, right? And these two are equal, right? F of x at x equals 2 also is equal to these limits, right? So that is also equal to 5, right? And therefore, and the function is finite in the neighborhood of x equals 2, right? So we established continuity in the open interval 2 to infinity in part 1, 2 to minus infinity in part 2. And when we examined continuity at x equals 2, we notice that the function is continuous at x equals 2, right? So we know that there is no point where this function is discontinuous, and we can comfortably say we can combine part 1, part 2, and part 3, which is our part 3, let me call this, and continuous at x belonging to R, right? So I hope you found this content useful. Please do subscribe to my channel and support. Thank you.